In this presentation, I will discuss the functions, food sources, and metabolism of vitamin D. Be sure to have your textbook opened and the presentation slide handout printed, ready for note-taking. Cholesterol is the precursor of vitamin D. Vitamin D is commonly called the sunshine vitamin because the liver uses cholesterol to make the vitamin D precursor. Therefore, there has been a long-standing debate as to whether vitamin D is a hormone or vitamin, as vitamins are, by definition, essential nutrients. This is another exception to the rule. Vitamin D is really a hormone and not a vitamin. When sunlight strikes the skin, 7-dehydrocholesterol is converted to cholecalciferol, or vitamin D3. Regardless of whether the vitamin D in your body was synthesized in your skin or consumed in your diet, it is inactive until it is chemically altered in the liver to form 25-hydroxy-vitamin D3. This is the form that circulates in the blood and is monitored to assess the individual's vitamin D status. However, 25-hydroxy-vitamin D3 is inactive and must be modified by the kidney to form the active form of vitamin D, 1,25-dihydroxy-vitamin D3. Think about it. What would happen to vitamin D status if the kidneys were not functioning properly? The answer is, the activation of vitamin D3 would not occur as it should. Vitamin D's special role in bone growth is to maintain blood concentrations of calcium and phosphorus. This helps the bones to grow denser and stronger. Vitamin D does this in 3 ways. 1. By enhancing absorption from the GI tract. 2. By enhancing the reabsorption by the kidneys. And 3. Mobilizing the calcium from the bones into the blood. Parathyroid hormone stimulates the enzymes in the kidney to convert 25-hydroxy-vitamin D3 to its active form, 1,25-dihydroxy-vitamin D3. Why, then, is vitamin D included in many calcium supplements? The answer is, vitamin D is necessary for calcium to be deposited in the bone. Interesting to note, when vitamin D is deficient, only about 10 to 15% of calcium in the diet can be absorbed. Active vitamin D binds to vitamin D receptor proteins in the nucleus of the cells in target tissues, similarly to vitamin A. However, vitamin D increases the expression of genes that code for the production of intestinal calcium transport proteins, thus enhancing the active transport of dietary calcium from the intestinal lumen into the body. This highlights how the major roles of vitamin D, bone health, and gene expression work together. Newer areas of research regarding vitamin D examines its other functions within gene expression. There are 2 forms of vitamin D, vitamin D2, ergocalciferol, which is the plant version that is also added to fortified foods, and vitamin D3, cholecalciferol, which is the animal version. In vitamin D deficiency, production of calcium-binding protein, or the protein that binds calcium in the intestinal cells, slows. Even when calcium in the diet is adequate, it passes through the GI tract unabsorbed, thus leading to a calcium deficiency. Rickets is not common in the U.S. In rickets, the bones fail to calcify normally, causing growth retardation and skeletal abnormalities. When the child starts to walk, their bones bend when they have to support the body's weight because they are so weak. Osteomalacia is a painful disease in adults due to poor mineralization of the bone. The bones become increasingly soft, flexible, brittle, and deformed. Factors that might contribute to vitamin D deficiency include dark skin, breastfeeding without supplementation, lack of sunlight, and not using fortified milk. Breastfed infants, children who don't consume dairy, and older adults are at highest risk for vitamin D deficiency. In the elderly, the skin, liver, and kidneys lose their capacity to make and activate vitamin D. This is age-related, as well as limited exposure to sunlight and poor consumption of dairy. 40 international units equals 1 microgram of vitamin D. The recommendations for vitamin D are based on the assumption of minimal sun exposure, as the amount of vitamin D synthesized in the skin is affected by so many variables. Synthesis of vitamin D from exposure to sunlight does not produce toxic amounts because the body regulates vitamin D formation. To review, can you remember what the action of sunlight on 7-dehydrocholesterol forms? The answer is cholecalciferol. So what are the rest of these? 25-hydroxyvitamin D3 is the inactive form of vitamin D produced in the liver and circulates in the blood. Parathyroid hormone is released by the parathyroid gland to increase blood calcium levels. And 1,25-hydroxyvitamin D3 is the active form of vitamin D that is converted to this form in the kidneys. To conclude our discussion of vitamin D, what is your final answer? The actions of vitamin D do not include regulating the thyroid hormone synthesis,